Good afternoon, ladies and gentlemen. Welcome to the second session of PyCon today. We all know Python is an object-oriented programming language. Most methods in Python have a self as argument. Do you want to know more about this self? Well, thyself. Let's welcome Thomas Ballinger. Know thyself, methods and methods bindings.
Great. Thank you. Appreciate it. All right, so we've got about 150 slides. Okay, let's go. So we want to talk about methods today, methods and method binding. We'll talk about what that is in a sec. Oh shoot, we got to get going. All right. So we're going to hit what Python methods are, how they work, and we're going to say that I'm going to advance this thesis that functions are the fundamental kind of unit, the fundamental building block in Python, out of which we build all sorts of things, including most of our object orientation. So quickly, what's up with classes? Well, say I'm running a newspaper in my hometown, and we have one customer, and I remember their address and how many days they've paid forward. And every time I deliver them a newspaper, I decrement that. But then I have another address. So maybe I don't want to keep making variables. So maybe I stick these in dictionaries, and I stick each of those dictionaries in a list so I could keep track of this data separately. So I have one subscription, another subscription. I'm calling these things subscriptions. And then there are things I might want to do with each of these, like deliver here. Each time I deliver a newspaper to one of these subscriptions, I want to decrement the number of days that they've paid for. Or I want to, when they renew, I want to increment that variable. Or if I want to know if they have a late payment and I need to send my paper delivery person over to knock on their door, then I have this isLate method. All right, sorry, it's a function at this point, right? These are all functions. They're all working on the same kind of thing. I can use them on these subscription objects, or they're really dictionaries with the right keys, right? I could loop over them and use them. But I'd really like to use this schmancier syntax. I'd love to be able to say sub.dayspaid here. It'd be 3 less characters. I'd like to be able to say this. So if I want to do that, I'm going to use a class. I'm going to store those variables in an instance of a class. I have this init to help me build that thing initially. And then those functions that I had here are going to use this different syntax. And then I'm going to move them in after I write my initializer code for this class. I'm going to move those functions into be methods. And how did I do that? Well, I took the functions, I indented them one level, I stuck them under the class, and then just to be good, I also changed sub to self. We don't have to do that. It's just a nice thing to help us understand each other. And now I can create these things. I can instantiate this one. I can call my functions on these objects, but now that they're methods, instead of calling the functions on the objects, I'm going to use this other syntax, where we take one less argument, and these functions are kind of namespaced, and we call them methods now. So what do we know about methods? They're these namespaced functions, and they take one less argument. Okay, so what are Python methods? Oh, shoot. So it looks like I'm out of slides. I thought we had a ton of slides that we were going to go through, so we're going to improvise here, and we're going to see what we can get done. I'm just going to have a conversation with you about, I guess. Okay, here goes. Okay, so let's start over. All right, so I've got this function here. I'm typing away here, type, and we also have methods. And what's the difference between these two? Well, we've already said, but it's just that one of them is in the class and the other isn't, right? So we've got, we call the function with 3 arguments here, and then we also are gonna, let's see, and we call the method, oh great, okay, this will work really well. So you can see the difference here, right, is that when I call that method on that instance with one too many variables, we see this error message that we're all real familiar with, right? Pretty confusing error message. It's saying, foo, this function I called it as a method, takes 3 positional arguments, but 4 were given. Well, I gave it 3. What's up with that, right? So it's kind of weird thing that we're accustomed to when dealing with methods like this. We'll come back to that. First, I want to claim that methods aren't really a thing in Python. There's a dramatic claim here. Well, I'm going to say syntactically, they're not really a thing in Python. Really, all they are is that we have a function, and we stick it in a class, and now we call it a method. We didn't do anything to it. It's just, methods are just functions. So the way I'm doing this here is we've got our class, and we've got a function object. I'm just sticking it on, and I made an instance. And now look at our autocompletion here. You can see that we're just using 2 arguments. So this is a method. So functions are just methods that happen to be living inside of classes. Would be the first argument I'd advance here. We get our same annoying error message, right? So these really are the same. To pound this home, to really drive this in, let's think about, let's use an alternate syntax for assignment, for making a class and making a function in Python, to really remind us that def statements and class statements are just assignment in Python. So maybe if we write it this alternate way, so Python gives us a syntax for functions that works as an expression, and we just bind it to a name. Python also gives us a syntax for classes that do the same thing. So, instead of doing a class, let's try, let's build the class dynamically like this, and then remind ourselves that that's what we're doing anyway, right? When you do a class statement, we're still just introducing a variable to our namespace and then creating a class object and binding it to it. And once again, all I have to do to make foo a method is just slap it on there. So now I'm going to have to call this with less arguments. Okay, so hopefully we're questioning what's going on here, right? How does this work? It seemed reasonable that maybe we were just reusing the def keyword inside of the class syntax, and that's what made it a method, but I'm claiming that's not how it works. So, well, I have a theory. I know this other language called JavaScript, and maybe that's how it works. So in JavaScript, we have this kind of interesting, if you're not familiar, this is JavaScript. We're in a browser here on one of the best websites, and what we're going to try to do is write a class. That thing's called a class, at least old-style JavaScript. I'm going to write a method now. Methods, just trust me, this is method syntax here. And the way these methods work in JavaScript are that JavaScript also doesn't really have methods. It figures out whether something's going to be a method or not based on how you call it. So the function we're going to try to call here is going to be this, similar to our newspaper example. Thankfully, one of those made it through, I guess. We're hoping that when we call this on the, when I call the function and I'm using a dot, so we're going to create, this is how we create an instance of one of these objects. And when I call it like this, it's going to work. This will be the right value. Now in JavaScript, you'll see we don't have to have that self first parameter, but we can tell if it's working correctly based on whether this is pointing to the right thing. But then if I store that method, if I grab that method off of here, put it in this variable called stored, and then I call stored, things aren't going to work correctly. And so that's maybe how we can test if it works like this. So I already understand how JavaScript works. It's based on what's on the left side of the dot. Maybe that's the way that this Python mysterious thing works. So let's take a look at that. We can kind of test this theory by seeing if we were to take a method off of a function, or off of an instance, is it still going to work? So we're back to our starter case here, create an instance. We've got foo, okay, which is the same as we've been. Works the same way. Let's grab that method off and see if we get the same error. I'm guessing, well, of course we can't call it with no arguments, but I'm guessing, it looks like it's going to work with 2 arguments. So that theory is kaput. That's not going to work. It seems like you can actually take a method off of an instance in Python. It still works just fine. So that's not it. That was a system I understood. I thought it was a little weird that it depends on the syntax of how you call it, but it made sense to me. I guess I have another theory, which could be maybe when we create an instance of a class, we take each of those functions that were in the class and we copy them over and we turn them into methods during instantiation. I know there's lots of black magic going on when we create a new object in Python. Maybe it walks through that list. So to check that, I'm going to create an instance and then add a new method to our class and then see if maybe we don't have that one anymore. So I created Baz. I'm sticking Baz on bar. And, well, shoot, it's there on our autocompletion. So somehow this instance, even though it was created after we added that function, or before we added the function to the class, it still works. I'm checking to see if maybe they're stored. Vars gives you the namespace of an object, and it didn't look like there was anything in there. And based on that highlighting there, yeah, it seems like it's still a method. So, okay, that theory is no good either. Okay, well, let's take a moment to appreciate, though, that it is pretty cool this stored thing works. So if we back up a bit, it's wonderful that these methods, we call it binding, and we'll see why in JavaScript in a sec, but it's wonderful that we do have these bound methods in Python. So if I, say, wanted to start a thread and I want to pass in a method, I can do it really easily here. I can just say, yeah, the B instance, call the foo method on that. That's what I want you to do in that thread. Or here's a more concrete example. If I have a dictionary like this, and I want to, well, okay, let's grab the keys off. Say that I want to sort those keys based on their order in that dictionary. If we didn't have this automatic method binding, I would have to say, like a sorted of those keys, and then I guess I'll write a little lambda function where I pass in a reference to the keys, the dictionary object, and then call whatever method is on there. But we don't have to do that. We can skip this part, right? We can just go straight to key equals d.get, because that get method will be passed through, and it's going to work on there fine. So it's pretty slick. It's pretty convenient, especially when you're kind of used to more of this JavaScript style, where we're going to see here, it works fine on that instance, right? But if I try to take it off of that instance, things are not going to work out. JavaScript has this great function called setTimeout that lets us call this function later, but it takes a callback, like those other APIs we saw in Python. So let's start it here. We're going to have to wait 3 seconds, is what 3,000 means. And undefined, so it was supposed to be printing true or false based on some value there, and this is not working. So there's something wrong here. And you can solve it by doing the lambda syntax that we have in JavaScript too, or maybe you could, you can call this special method on function objects called bind in JavaScript, and that'll do it. But it's super great that we just have this for free in Python, and we should appreciate it. But it's still mysterious to us. So this, yeah, sure, this works. That's a lot of typing. Okay, well, I'm looking for hints somewhere else. We've got, back to our old style thing, we create this instance, we try to call the method with the wrong number of arguments, and we get this weird error. Well, I recognize this from somewhere. Where is it? I think it's when I've been partially applying functions, is when I've seen this before. So if I take a function and I try to partially apply it, meaning just use some of the arguments, then I end up with a function that behaves similarly, where, yeah, it takes less arguments, but it doesn't, oh, shoot. I typed too fast for a sec. We're way ahead. Okay. So we're doing this partial stuff here. Does this match? So we're jumping ahead considerably. This is this idea that if we have this partial thing, partially applying is this idea of let's create a new function that's similar to the old one, except it takes less arguments. And here I'm reminding myself that I guess I could use that partialing thing to create a method. So I'm calling this thing methodize for, all right, let's turn a function into a method by partialing it. And right about here is where I realize that, okay, I'm going to need the instance. So this is this idea of take the function, apply that first argument of the instance to it, and then methodize is the same as partial, it turns out. But I bet we could end up with a thing that looked a lot like a method that worked in a similar way. So let's give this a shot. If we look for foo on our bar thing, we could methodize it by partially applying it to our instance here. And now I'm going to say we have that method, and look, it kind of works. But the real test is right now when we see, do we get the same funny error message? Because that's really what we're looking for. But I guess we're too smart to type it this time, so we'll have to see. This is working pretty well. So maybe this is the kind of thing that's happening. Maybe somehow, it's confusing about when that would be happening though, but somehow we're calling this kind of methodized sort of thing on that function, but it's pretty weird because on the actual, well, okay, this is going to clear it up a bit. Let's look at what those objects actually look like. I think we might not have tried this yet. So once again, let's build our function. It's a function. We hadn't seen that yet. It's a function, interesting. And then this thing, what is it? If anyone was at trivia last night, oh yeah, it's a function still. Interesting, huh? Now it's a bound method. Okay, so that transformation is happening somewhere in between there, which is just pretty weird. How is that looking up process different? So far, we know that methods are not a syntactic construct in Python. This is great, I found a slide, phew. Bound methods are really useful. They're great, and you miss them in languages where you don't have them. And this binding of methods, this building the method version of something is mysterious. We still don't really understand. But it seems something to do with this partialing, hard to tell. Okay, well, let's go ahead because I have some secret special information for you, and that is that there is a way, this get thing, there's a way to totally change the way that attribute lookup works in Python. If you have a class with a get method, and then you create an instance of that class, and you put it on a function like this, or a class like this, we might imagine that instance lookup, attribute lookup on an instance, you look at the instance, then you look at the class, then maybe you look at more classes. But if you put this weird thing on there, you get not what we put there. We put T was supposed to be a thing object, and we ran this code. So here's a weird thing we could use to build this kind of behavior ourselves. It turns out that on attribute lookup, you actually get to totally customize what comes out of that. So, this thing's called the Descriptor Protocol. I'm giving it away now. The Descriptor Protocol is the magic that makes all of this work. The Descriptor Protocol is this description of a little bit more advanced behavior. It's saying, you know what, when you look something up on a class from an instance or from a class, what am I going to give you back? And it's a little bit, so here you can see the API is that it's going to be self-instance owner. Each time you go to look up this thing, what we get back is going to be whatever is in that return. So this time it's going to be 7 each time. It's demonstrated in this code. So that means we could implement methods. So let's take a shot at this. We could implement these instance methods that behave differently based on whether they're looked up on an instance or looked up on a class. Because I should mention, that's the behavior we're looking for. That's the really weird behavior of if we look it up on capital F foo, we get just an ordinary function, but if we look it up somewhere else, we get a method. So let's make a little wrapper kind of thing. This looks the same too. Let's move on. Oh dear. We'll get to this. Gosh, it seems like these aren't working either. Shoot. I guess we have to go all the way, don't we? So you're really not supposed to do this, but here we go. Getting exciting. Got it real big for you all. Everybody see that? Okay, we're a business. All right. So our goal here, what thing we're trying to do is reproduce this descriptor behavior. So we've got our class bar here. We've got our foo thing. Our goal is to write a descriptor that will take, let's have it, I'm going to call it class kind of method wrapper. And what it's going to do, we'll give it a nice init so we can pass in that function that we're going to wrap with this behavior. Because it turns out what descriptors are all about is let's wrap a function or something else with some behavior that customizes how it works when it gets looked up on an instance or a class. So let's do let's save this guy, and then we have to implement this method here, get instance owner. All right. Now, this is a little tricky. We're trying to implement some behavior where when we look it up on an instance, we get back a method. So I'll do that one first. So I'm going to say if instance is not none. Instance, it turns out, is going to be none when we look it up on a class. So if instance is none, then let's say return just self.function. We're just going to return the pure function itself. But otherwise, instance is something. And let's return the partial of self.func with the instance that we called it with. Cool. Better remember from functools import partial here. Now, hopefully, if we have this class foo here, we could now say something like, I'm going to call it our fancy function, fancy func equals the method wrapper of, and I forgot to write a function, so I'll just write a lambda right here. A good old A, B, C, none. And we're just going to be figuring out if this works by looking at the signature. Okay, so f equal to foo. If we look it up on the class, we're hoping that we get back, yep, a function. And then if we look it up on an instance, we're hoping we get back some kind of partially applied function that takes less arguments. All right, 2 arguments. Great. We did it. Terrific. Thank you. But next I want to advance that this is a more common pattern. This is a bigger pattern in Python than just these instance methods. So first, we haven't seen that wrapper yet. Well, okay, turns out the reason we haven't seen that wrapper yet is because just totally ordinary functions just have it. So if I write a function here, foo.get is a thing. So we don't have to add these wrappers. Functions just have them automatically. In fact, it's called a method wrapper. So it's a thing that turns a function into a method when that's the appropriate thing to do by calling it from the class or from an instance of a class. But then we have some other ones. There's static method, which is different behavior, right? This is a wrapper for a function that causes it to be looked up differently. There's another one called class method, right? And this is, again, a wrapper for a function.
Another sector of the building has reported a fire alarm condition. Management is investigating. Please remain calm where you are. Please wait for further instructions.
Okay, we'll stay pretty calm. As calm as possible. This is pretty exciting stuff, though. We'll see. We'll see. Okay, we're so calm. We're good. So we've got several different other wrappers for functions that change this behavior, right? We have class methods. We have static methods. We also have properties, which are also a wrapper for functions to give us object-oriented behavior that isn't natural for functions. So I want to claim here that functions are the fundamental unit of kind of everything, but in particular of object orientation in Python. So Python, we're wrapping things with properties, we're wrapping things with static methods, we're wrapping things with our class methods, and then the default is to have this special behavior for instance methods. I would encourage you to look more into this. Great resources, I think, are the data model doc. That's for so many things. In the official docs, you should check out the data model and documentation. The descriptor how-to guide by Raymond Hettinger is, of course, good. There's a great article called How Lookup Works, because this lookup stuff's a little more complex than it seems like it would be. The descriptor things, because there's a get and there's a set, it happens in 3 different passes. There's special methods or special cased. So things get interesting, but we maintain this purity of having a single kind of function. There is a function, and that's it, and it behaves in one way, versus having like, okay, we also have methods that behave in this other way, or when you add, a self keyword. And actually, I mentioned this last post because Guido, during, when Python 3 was coming around, we're like, let's roll out all the cruft. Let's get rid of anything that seems kind of not ideal, and having to write self over and over and over seemed like one of those things. So there were several proposals like, okay, how could we rip self out of here? And I don't want to comment too much on like different ways. It seems like a language design thing, but Guido has some great comments on at least why this would be really hard to change. How baked in this partial application of a function to create a method is into Python. Because for everything, we start with functions, and then we turn them into some other kind of thing to produce this object-oriented behavior that we expect from other places. So that's it. So if you have time, I'd love to take. Oh, good. I'd love to take questions, particularly if there. Do we have 5? Yeah, great. I'd love to take questions, particularly if they're the kind of thing we might be able to answer by exploring with each other in the terminal. There's mics here and here, or if you're loud and there's no one at a mic, I can repeat your question. I'm going to hold you to it. I'm not going to say there's no questions and so we can go. You're still welcome to go, but. All right, I think, given this is up, I think maybe we're done. Okay, thank you.